Hello everyone. In this presentation, we will be talking about IBM blockchain. IBM blockchain is a platform by IBM that offers blockchain-based solutions to businesses. To understand IBM blockchain, we should first understand what blockchain is. As the name suggests, blockchain is a chain of data packages, otherwise known as blocks. Now, what exactly is a block? A block is a name for a small amount of data. For example, if we are dealing with financial transactions where each individual transaction is small, it is the details of when, how much, who's it from, who's it to. Each block can hold the details of several hundred to a couple of thousand transactions, and when new transactions happen, they get patched together into a new block. This block is then added after any existing blocks. And the chain idea is vital here because a blockchain grows by having more and more blocks appended to it, just added on the end. And they're always added in sequence. We cannot add a new block in the middle. We cannot rearrange the existing blocks. We cannot just delete an earlier block or edit it. The term sometimes used is that blockchain is append only. To understand why this is the case, let us look at cryptographic hashing that takes place in every block. For each block, we have a hash value, which is calculated using the data contents of the block. For example, if a simple sentence were to be stored in a block, the hash value can be calculated by taking all the letters of the sentence and then changing every letter to its corresponding number in the alphabet, like A would be 1 and B would be 2. And this would give us a unique hash value for that block derived from the data. So that each time we calculate the hash, we get the same value, and any changes in the data will result in a different hash value. The hash value stored in the block along with the hash value of the previous block. Therefore, if there is any change in the data, the hash value is also changed, which leads to a disconnect with the next block. The main features that make blockchain unique are as follows. Blockchain is decentralized. As a distributed ledger, blockchain is built on a peer-to-peer network and does not require a trusted third party or a central administrator. Multiple copies of data recorded in ledger exist in the system, avoiding data loss at a single point of failure. Blockchain is tamper resistant. Blockchain uses consensus protocols, that is proof of work, to manage the right to create new blocks. As a result, data manipulation is impractical in terms of computational overhead, making the data recorded in the block immutable. Blockchain supports traceability. The remaining participants can easily verify transactions between two parties in a blockchain system, and any and every transaction can be tracked. As we can see by now, blockchain is decentralized, and thus the storage system is also decentralized. First, the storage system breaks data into smaller and more manageable chunks that can be distributed across nodes. Then the system encrypts or locks each data chunk on the local system to ensure no one can access the data except the content owner. Next, the blockchain storage system creates a unique hash and encrypted output string based on the data or encryption keys. The hash is added to both the ledger and the data metadata to link transaction to the stored chunks of data. The system then replicates each chunk a specified number of times to ensure enough copies to prevent data loss. Next, a peer-to-peer network distributes replicated data to geographically dispersed storage nodes owned by individuals called farmers, but the data is still only accessible to the content owner. And finally, the storage system records all transaction details like data location and hash in the blockchain ledger and syncs that information across all nodes. The exact approach to blockchain storage will vary depending on the storage system use cases and how the data storage is managed. As we know, the data is stored across nodes, but not all nodes have the same functionality. A full node is a node that fully enforces all of the rules of the blockchain, while a light client, also known as a light node, is referencing a trusted full node's copy of the blockchain. This means that you can transact on the blockchain without downloading an entire copy of the blockchain. Now let us talk about IBM blockchain and its key features and how it is different from other implementations of blockchain technology. IBM's blockchain is built on the Linux Foundation's open source Hyperledger Fabric version 1.0. Unlike other blockchain implementations such as Bitcoin or Ethereum, Hyperledger Fabric fulfills all four key elements of a blockchain for business. It is a permission network. That is, it provides collectively defined membership and access rights within a business network. Transactions are confidential as it gives businesses the flexibility and security to make transactions visible to select parties that have the correct encryption keys. It doesn't rely on cryptocurrencies and therefore doesn't require mining and expensive computations to assure transactions. It is also programmable and leverages embedded logic in smart contracts to automate business processes across a network.
Decentralization. Now let us understand what is decentralization in IBM blockchain. Decentralization is the process of redistributing or dispersing functions, powers, people, or things away from a central government or location to a lower or a dispersed level. Or in the other words, it is explained as an ecosystem model of identity management where users generate and manage their own digital identity without relying on a central repository or database. Decentralization refers to the transfer of control and decision-making from a centralized entity to a distributed network. It prioritizes security over network. Decentralization have different objectives such as effective control and supervision, development and managerial personnel, to reduce the communication work and fill the gap in communication if any, to take quick and appropriate decision at the level which it is really required with a view of exploiting an opportunity available, reduces the burden of top management, prompts decision making, flexibility, and it motivates and boosts morale. Benefits of decentralization. It provides trustless environment, more flexibility and greater speed in reacting to changes in the environment. Decentralization ensures better control and supervision as the subordinates at the lowest level will have the authority to make independent decisions. Resource distribution is achieved. Promised services are provided with better performance and consistency. Quick decision making. Decentralization brings the decision-making process closer to the scene of action. This leads to quicker decision-making of lower level since decisions do not have to be referred up through the hierarchy. Decentralization allows individuals to enjoy the benefits of ownership.
To understand security considerations from an IBM blockchain standpoint, it is especially helpful to understand the CAP model. The CAP model specifically applies to a distributed system, a system composed of many nodes that are interconnected on a peer-to-peer network, which explains what the IBM blockchain is. There are three core underlying principles that inform the types of actions the distributed ledger is structured to handle. 1, consistency, 2, availability, and 3, a partition point. The first is consistency. Each node receives timely information. 2, availability. Submitted transactions are permanently added into the ledger and readily accessible to network peers. 3, there exists a partition point. So there's a failover or save point that exists, which is operational and accessible. So let us say there's a network failure and the users are operating on the blockchain. Well, they can revert back to an earlier point in history in which the blockchain was readily accessible and usable. The theorem broadly holds that at the very least 2 of the conditions must hold, though practically all 3 elements have to be present, and this is especially true for IBM blockchain. Cryptographic hashing is also really important and occurs in the form of 2 data structures, the Merkle tree and hash pointer reference. Hashing is the process of taking a particular set of data and transforming it through an algorithm into and generating an output of a fixed length. This fixed length value becomes permanently associated with its underlying data. A slight change to the hash value disables accessibility of underlying data. The hash pointer reference. Hash pointer reference at its core, the hash pointer reference is essentially a reference to a store of data. IBM blockchain utilizes hash pointers in the underlying structure of a single block within the blockchain. The underlying structure of a block has a hash pointer reference as a unique identifier. This hash pointer also references the preceding block. The hash pointer also provides an anti-tampering measure. Any attempt to modify a block in turn modifies its hash value. Modifying the hash value then in turn invalidates the reference to the preceding block. This cascading effect travels all throughout the blockchain, resulting in a blockchain that is inoperable. Merkle tree, a data structure that has apparent nodes at the base level providing references to succeeding child generation nodes. This data structure presents the ability of linking with succeeding nodes. Any change to a node must be in accordance with nodes that are derived from it. Change one without the consent of others, and the entire tree falls apart. Digital signatures. Digital signatures are part of a transaction. These are manifested in the form of a public and private key. The blockchain is essentially a recorded history of transactions conducted on the distributed ledger system. The blockchain uses asymmetric encryption in the use of both private and public keys to add transactions to the blockchain. So each transaction comes with its own specific private key that in turn has to link up with the system that has a public key. Now, in order to append to the blockchain, the system has this public key with an encrypted message. But just because you're in possession of that public key from the blockchain system, you cannot access the blockchain or append to it through transactions. You have to have your own copy of the private key, which is given to you and is unique to you. This private key has an instruction set on how to de-encrypt the encrypted message from the public key. This interaction between the private key that the user has and the system's public key enables one to append to the ledger in the form of transactions. This interplay has to be maintained, and any attempt to modify the private key renders it useless. The consensus algorithm. The consensus algorithm is a unifying mechanism that collates information from the digital signature and hashing data structure to add a block into the blockchain. Following the implementations of hashing digital signatures, the consensus algorithm permits the addition of a singular block to the existing chain through a two-step process. One, broadcasting the node to the entire network of users for that specific blockchain, and two, permitting each node to add to the block to their copy of the global ledger. Crucially, the consensus algorithm functions as a feedback mechanism which derives inputs from the digital signatures and hashing mechanism to permit the addition of a block to a chain. Any disagreement amongst any of the subcomponents and the block is not added. Everything comes together in the form of the IBM chain code. The chain code is a term to describe applications that use business logic to interact with the blockchain ledger. They are the underlying programs that are stored within the block. Chain codes are smart contracts in IBM blockchain context. The chain code make use of containerization, specifically through Docker, permitting the user to scale resources to applications as needed. The IBM chain code maintains an activity history of the blockchain by storing information on digital signatures and overall activity history. This component allows a user to track changes and remove fraudulent entries.
So now that we know the technical and security features of blockchain, we can now dive in and learn about IBM's specific implementation of its blockchain platform. IBM's blockchain platform is based on the open source Hyperledger Fabric version 2.0 from the Linux Foundation. Fabric protocol allows for modularity, which can allow for a variety of pluggable implementations such as cryptography, identity protection, consensus protocols, smart contract languages, and many more interchangeable plugins that are based on the consumer's needs. Customers can also use popular programming languages such as JavaScript, Java, Go, and many other languages on IBM's platform. They also include a big extension for the implementation of Visual Studio Code, which IBM actually highly recommends or has support for. This helps create quick smart contract projects and allows for the rapid development and testing of these smart projects with just a click of a button. IBM blockchain also has a very specific and clear defined tools for key governance, which is one of the more important features of a decentralized business model. IBM allows for customers to have two different deployment options. Customers can either host their networks on IBM's infrastructure and hardware, or they can use their own network using Red Hat OpenShift to keep a copy of their own ledgers and run workloads on their own infrastructure. With all these features, IBM's platform allows customers to have pretty tight control over their blockchain network and allows for customization with tight security. Now we will see some real-world examples of the IBM blockchain platform being used in certain industries and companies and see the benefits that blockchain has provided in these fields. IBM has been very active trying to implement their blockchain technology into the mainstream market. Some big companies have started logging transactions between banks and international businesses and allowing the two to share the same record-keeping system. Some of these companies include JP Morgan Chase, Wells Fargo, State Street, Swift, Cisco, Intel, and many more. The fact that blockchain ledgers are immutable makes them particularly advantageous in the financial market, as it makes perfect for record keeping and keeping the integrity of transactional data. The data used can also be used for companies to log data for support forensics as well as compliance information. Due to blockchain's advantages of data integrity and security, it helps give consumers and businesses more of a peace of mind. The first wave of companies also provide good data for defining the solutions to securely run these implementations in the cloud, providing real-world applications to set a standard on how blockchain can be implemented going forward. Due to the ledger system and smart contract feature, blockchain has allowed financial institutions to have less errors, increased efficiency, improved customer experience, and a huge reduction in capital consumption. Now let's explore how IBM has created a similar solution for the food supply chain industry. IBM has introduced their food trust platform that utilizes blockchain technologies to help food companies provide better supply chain transparency and efficiency. This system actually stores data for about 1 million food items currently, which is shared across the entire IBM blockchain platform. IBM Food Trust uses their blockchain technology to connect participants through a transparent, permanent, and shared record of food origin details, processing data, shipping details, as well as much other information about food origins. With this network, IBM Food Trust has been able to log over 35,000 food data transactions. IBM has also noted that food recalls can be as much as 80% more efficient to respond as opposed to using a traditional supply chain system. Starting in September of 2019, Walmart and its Sam's Club division suppliers of fresh leafy greens started implementing real-time end-to-end traceability of products back to the farm using a digital ledger system developed by IBM. They plan on making similar mandates for their fresh fruit and vegetable providers, but have stated that leafy greens have constantly been found as root cause of some recalls due to E. coli outbreaks and other kind of similar situations, and that implementing this blockchain technology can hopefully speed up response times in case of a foodborne illness or recall. IBM also plans on working with over 10 other companies implementing their food trust platform, including Dole, Unilever, Driscoll's, and many more. Here is a quick sample of a food item moving through IBM's food trust. In this example, it's an apple moving to apple puree. So as you can see, there's kind of a flow chart of how a food item arrives, say in this case, the farm to the manufacturing plant to the, in this example, Walmart warehouse, and then to the store. And as you can see, it kind of shows every step along the way of the apple getting either loaded, unloaded, being transformed, and how it kind of is recorded. So in IBM's Food Trust, they use 6 classifications to kind of log every step of the way, including commission, signifying creation of an object, decommission, deletion of an object, transformation, irreversible transformation of an object, aggregation, which is the grouping of objects, disaggregation, which is ungroupings of an object, and observation, which is essentially just a general observation for the object. So these are all kind of combined in the master data, as well as the locations of the item, as well as item numbers and lot data. So essentially all this information is compiled and essentially stored in the blockchain network, and essentially provides a reference point for kind of the food process of, say, the apple to apple puree, and essentially provides a proper reference point that you can kind of go back and see the origin of the product.
Blockchain in food supply chain. This is the explanation of how blockchain is enabled in the food supply chain. Third-party logistics will have all the information about the origin and the destination of the product. They will also be given the instructions on how to store the product. Now it will be sent to the retailer, and they will run a machine learning based forecasting on the product. It will add updates to data records. Stores will make sure that they have full transparency on the delivery times of the product. Additionally, they will adjust and adapt their orders, promotions, and other items according to the delivery. Lastly, the customers can scan QR code with the specific app. Now they can gain insights into the origin of the certain products, aging, duration, and other items about the specific products. Blockchain in healthcare system. Blockchain particularly helps in storing patient records. Blockchain associates client data by the private key. Use of public key by admin users ensures protections of the patient's clinical information. Permits large cooperation between clinics, hospitals, and healthcare providers.